Security for cloud applications is critical to protect your application's data and infrastructure in the cloud. Here's an overview of secure development practices, DevSecOps in the cloud, and serverless security considerations. Secure development practices. Threat modeling. Start by identifying potential security threats and vulnerabilities in your application. Conduct threat modeling exercises to understand where security risks may exist. Secure coding standards. Develop and enforce secure coding standards within your development team. This includes practices like input validation, parameterized queries, and avoiding hard-coded secrets. Penetration testing. Regularly perform penetration testing to stimulate real-world attacks on the application. Address vulnerabilities and weaknesses identified during these tests. Security testing tools. Utilize automated security testing tools, example static analysis, dynamic analysis, and dependency scanning, to identify vulnerabilities and early in the development process. Code review. Conduct code reviews with a focus on security to catch vulnerabilities and issues before they make it into production. Least privilege principle. Implement the principle of least privilege to ensure that application components and users have only permissions necessary to perform their functions. DevSecOps in the cloud. DevSecOps culture. Essentially, it is a cultural shift that integrates security into the DevOps process from the beginning, encouraging a culture of collaboration and shared responsibility among development operations and security teams. Automation. Use automation to incorporate security checks and tests into the CI/CD, continuous integration, continuous deployment pipeline. Automated security scanning and testing help identify and remediate issues faster. Infrastructure as code. Implement security best practices in your infrastructure code to ensure that the cloud resources are provisioned securely. Leverage tools like AWS CloudFormation or Terraform to define infrastructure. Immutable infrastructure. Promote the use of immutable infrastructure where changes are made by deploying new instances rather than modifying existing ones. This reduces the risk of configuration drift and simplifies security updates. Continuous monitoring. Monitor application and infrastructure logs and metrics continuously to detect and respond to security incidents promptly. Now let's review serverless security considerations. Function-level security. Secure serverless functions by defining appropriate executive roles and permissions. Limit access to resources and ensure that only authorized users or functions can invoke them. Environment variables and secrets. Store sensitive data like API keys and database credentials securely using cloud provider secret management services. Avoid hard-coding secrets in your code or configuration files. Dependency security. Regularly review and update dependencies in your serverless functions to patch known vulnerabilities. Use dependency scanning tools to automate this process. Cold start attacks. Be aware of the potential cold start attacks where the initial invocation of a serverless function may be slower. Implement appropriate security controls and timeouts to mitigate these risks. Monitoring and logging. Implement robust monitoring and logging for serverless functions to detect and respond to security incidents. Use cloud-native tools or third-party solutions for comprehensive visibility. In summary, securing cloud applications involves a combination of secure development practices, integrating security into the DevOps process, and addressing unique security considerations for serverless architectures. By adopting these practices, organizations can better protect their cloud applications and data in an ever-evolving threat landscape.